Let's take a look now at a GMAT format problem testing our knowledge of the area of triangles. So we said before the formula for the area of any triangle. So this isn't true just for right triangles. This is for any triangle. Area is equal to 1/2 base times height. Now, when you are given a right triangle is when you most often see this formula pop up, because with right triangles, it is very easy to determine what the base is and what the height is. If you have a non-right triangle, though, you have to think for a little bit, because depending on what you choose as your base, well, the height is going to be dependent on that, on what you choose as your base. So we'll talk about that in a second. A couple of things just about the area of triangles as they are tested on the GMAT. You are not going to see, it is never going to be as simple as having this formula memorized. Even though all of you should have this formula memorized, absolutely, you're never going to see, for example, a data sufficiency question where they ask you for the area of a triangle, and then statement 1 says the base is equal to 2, and statement 2 says the height is equal to 3. You are going to have to know this formula, but you're going to have to apply it in some sort of way that involves logic or deductive reasoning of some sort. Another thing, so if you have a data sufficiency question, as we do here, and they're asking you for the area of a triangle, and so maybe you write out your formula here, and then you say to yourself, because you are familiar with data sufficiency, oh, this just means I can rewrite this question as what is the base and what is the height, because that is what is needed to find this area. Well, you would not want to do that necessarily, because remember what data sufficiency is asking. Data sufficiency is asking for what is the minimum information needed to answer a question. So even though it is true that if you can find the base and you can find the height, you will be able, that will be sufficient to find your area. You do not necessarily need both of those two things, because if you can somehow find that BH is equal to 10, well then, without knowing what your value for B is or what your value for H is, you can now find the area of your triangle. So you would just sort of want to leave it like this. Or if you did rephrase it, if anything, you would just want to say, what is BH? Because technically, that is the minimum information needed to find 1/2 B times H. So with that in mind, let's take a look at this problem. In the figure shown, ABCD is a rectangle with center at point E. What is the area of triangle DEC? So that is this triangle here. So to start, let's just, they don't give us much information from our prompt here, but let's just use our knowledge of triangles and rectangles to label what we do know. So what do we know about rectangles? So first they tell us this is the center here. And then they tell us that we have a rectangle. So from, if you haven't yet looked at the quadrilateral videos, we will go through all the properties of all of our quadrilaterals. So for rectangles, I know my opposite sides are equal to each other. If I call this X, this side here also has to be X, and we call this side here Y. This side here also is going to be Y. And I also know all of my sides, all of my corners are 90 degrees. So I'll just label one of them. But I also know that my diagonals are bisectors of each other. So they split each other in half. They are not perpendicular bisectors. If they were perpendicular bisectors of each other, that would make your rectangle a rhombus. And actually, when you combine a rectangle and a rhombus, you have a square. So for a rectangle, you just know that your bisectors are your diagonals are bisectors of each other. Now, they'll be bisectors of each other, so that means they split each other in half. They're also going to be equal to each other. And that is just because you have these right triangles here that have the same legs, X and Y. Therefore, they should give you the same values for each of those hypotenuses, which are the diagonals. So they will be equal to each other, and they will be bisectors of each other. So that means BED is the same length as CEA. Now they were asking here for triangle DEC. So we said that is this guy here. And so if we say CD, this guy here is the base. So we're looking for 1/2. We're looking for the area of triangle DEC. That should be 1/2 CD. We said it has a length of X times the height. So what would the height be? So this here, remember, it's not a right triangle. So we have to figure out what is the height that corresponds with this base here. So if CD is our base, the height is always going to be a line. It has to be perpendicular to the base to form a 90-degree angle with the base, and then it connects to the opposite vertex. So this line here is our height. So we want EX to be just the length of this side. At this point here is F or something. So our area for triangle DEC should be 1/2 CD times EF. What do we know about those two values? We already said CD has a length of X, so we'll say 1/2 X. Then what is the length going to be of EF? Well, remember, E is the midpoint of our rectangle. So if our rectangle has a length of Y and EF just goes from one edge of your rectangle to the middle, well, that should be half of Y. And so our height for this triangle here, which we said EF, is really just 1/2 Y. Therefore, the area for triangle DEC is just 1/4 X times Y. So we can think of our question. Remember, all we've done so far is we haven't looked at our statements. We've just looked at our prompt. But really, we've sort of rephrased our question. It might seem like we really haven't done much because we already knew that area of a triangle is 1/2 base times height. So we just swapped our B and our H for an X and a Y. And we also changed our 1/2 to a 1/4. So it might seem like we didn't do anything. But the point is this. I see that I have all these sort of different triangles in my rectangle. And so I can put them all in terms of X and Y. So if I can find this triangle here in terms of X and Y, then maybe I can get the rest of these triangles also in terms of X and Y. Then I'll be able to compare them to each other. This is what we're looking for. We're looking for 1/4 X times Y, which really just means we're looking for X times Y. Triangle BEC has an area of 4.5. So which triangle is that? Now, make use of my big diagram I put here. EC, D, A, B, Y. So if BEC is this triangle here, they said this has an area of 4.5. So we got to figure out how is BEC related to this triangle adjacent to it, DEC. And this is where having everything in terms of the same variables is useful. So what is the base for triangle BEC? It's this line here, BC, which is just Y. So what they're saying in statement 1 is the area for BEC is equal to 1/2 Y. And then what about its height? Well, its height will be this line here. And so what is this? Well, the height of our rectangle, or the width of our rectangle, is X, right? And this line here goes from this top side here to the center of the rectangle. This should just be 1/2 X. The area for BEC is 1/2 times our base of Y times our height of 1/2 X. This is equal to, they said, 4.5. If we simplify this now, what does this mean? This means BEC, the area of BEC is equal to 1/4 Y times X, which is just equal to 4.5. What are we looking for? We're looking for 1/4 X times Y, which I believe is the same thing as 1/4 of Y times X. So this here, this is telling us these two triangles are actually going to have the same area, even though it sort of looks from the picture like they don't. You can't always trust that your diagrams are drawn to scale. They should have the same area, and therefore this area here of BEC is the same as the area for DEC, and this statement is sufficient. Statement 2. Diagonal BD has a length of 3 rad 5. So from B to D is 3 rad 5. So if we go back, remember what we said about the diagonals for a rectangle? They're going to be bisectors of each other. So each of our halves for our diagonals is going to be 3 rad 5 over 2. DE is 3 rad 5 over 2. ED should also be 3 rad 5 over 2. Then AC, because that is the same diagonal as BD in terms of its length. So this here should be 3 rad 5 over 2, and AE will also be 3 rad 5 over 2. So that gives us a bunch of isosceles triangles. So we'll talk more about isosceles triangles in a bit, but if you already know what they are, so two of the legs of these triangles are equal to each other, which means the angles opposite also have to be equal to each other. But can we use that to find the values for any of our other sides? So specifically, I want to find either the base or the height of any of my triangles. And I don't think I really can. One thing you do not want to assume, do not assume that these diagonals evenly split our corners into two 45-degree angles. That is not true for a rectangle. It is true for a square, but it is not true for a rectangle. So unless we knew that this rectangle was a square, we cannot make that assumption. So if we could make that assumption, then our two triangles here that our diagonals split a rectangle into, those would be 45, 45, 90 triangles. And we actually would be able to find all of our sides, and therefore we would be able to find the area that we are looking for. But because we do not know that, I don't think we can label anything else. Therefore, this statement is insufficient. And so we're left with just A as our answer. We will take a look now at some of the properties of our special triangles, such as isosceles triangles and 45, 45, 90 triangles. This was just a preview. Let's move on to that.